Hello and welcome to session 144 in the AISafety.com reading group. Tonight we have Rohin Shah joining us from the Center for Human Compatible AI, and he will answer some of the questions that we have that have come up during the discussion of the value learning sequence. Hello, Rohin. So the first question is with regards to non-goal-directed artificial intelligence and agents. What is the central example of a non-goal-directed AI that you have in mind when you wrote this sequence?
I don't know if I have a central example of a non-goal-directed AI. I think I had central examples of goal-directed AIs and was thinking that it might be possible to not have one. But perhaps one example could be firstly, there's all of these good old-fashioned AI expert systems that were doing basically symbol manipulation in order. One thing you could have imagined that they were doing was symbol manipulation in order to answer questions or generate stories or things like that. And sort of notably, there's no utility function or loss function that they're optimizing. They're just manipulating symbols according to rules that we program in, and then out comes an answer. And I don't think it was a priori obvious that such an approach couldn't have led to very powerful AI systems. Yet I would just not expect any of the problems that we think about with goal-directed agents to show up with such a system if it did become super intelligent. Now it turns out that okay, we investigated this approach and it didn't really work. But sort of if I take the position of not having run that experiment and said, could we build a symbol manipulation AI that works? I don't think it was obvious that the answer was no. Yeah. Another example would be basically probabilistic inference-based approaches. So you could imagine a system, again, let's say a question answering system, that basically, well, maybe that one has a similar flavor to the expert system, just with more probabilities thrown in order to make it less rule-based. But that one also would not have a loss function or an objective function that it's maximizing or minimizing. And I wouldn't expect the normal problems to arise then either.
Okay, one more thing. If people have questions or would like to ask a question, then please in the chat window, please write that you have a question and I'll maintain some kind of queue. And until someone says they have a question, then I will just ask some of the questions that people have sent to me. So the next question is actually from a children's movie that my children are watching about a aardvark robot, because this is one of the examples that you give of a non-goal directed agent, and agent that always chooses the action that starts with the letter A. And it's further an imitation agent in that it imitates an aardvark, but it's still obviously. So is this an example of a non-goal directed agent?
Yeah, I think if one of your actions is aardvark imitation, then I don't know. I was imagining something more the actions are things like move left, rotate your arm in some way, and things like that. And I think if you imagine actions at that low a level, then it's pretty clear that this should be a non-goal directed agent. It's going to do just random stuff in the world that's really not going to be trying to optimize the world in any way. It's not going to be subject to any of the convergent instrumental subgoals because it's not maximizing anything. It's just a very simple computation. It's look at the names of my actions, which one starts with A, and then choose that one. Now, if your actions themselves are complicated enough that they can be modeled as goal-directed, like aardvark imitation, I mean, then sure, maybe that would be goal-directed. I could believe that. But I was not imagining such complicated actions when I gave that example.
Okay. One of the other well, you give a number of non-goal directed agents, and I've tried to write all of them down here with like a hierarchy. The lowest is an agent that doesn't take an action ever. That's probably not goal directed. And then there's another few kinds, 1 to 4, which to me are obviously completely useless, basically. And then there are a few that are a bit more substantially less useless, but become more useful the more goal-directed they are. So is there a strict trade-off between how useful and how goal-directed they are?
That seems plausible. I am not totally sure. Like I said, I think an intuition I have is that, like, a priori, we didn't know that expert systems wouldn't work, and expert systems seem like they're not goal-directed. But sort of, we then did observe the fact that expert systems didn't work, and this, I think I've become a bit more sympathetic over time to the notion that, like, goal-directedness is pretty strongly correlated with usefulness. I think most of my point in this sequence is more that, like, it's not a, like, law of math that AI systems must eventually become goal-directed. It's definitely dependent on what we actually build. But it seems, I think there's a reasonably compelling case to be made that because of how useful goal-directed agents will be, we will end up building them. Looking at this hierarchy, I think it seems basically right to me. I'll note that, like, number 7, I think that one, the one where you have an agent that helps the goal of some other agent, goal-directedness might not be the right concept for this one, but it does seem both useful and more safe. Whether it's or not it's goal-directed, I'm not sure. Maybe this just means that goal-directed is not exactly the right concept for what I want to think about. But, like, that's sort of, I think that kind of agent is an example of an agent that might not have all of the safety risks that we associate with explicit expected utility maximizers, but still is very useful.
Okay. I think there's a question in the chat. Robert, please go ahead.
Yeah, I just was wondering about the this lexicographic sorting. It's distinct from an agent which wants to take actions that are high in the alphabet. Because, like, if you have enough of a time horizon, then you might have convergent instrumental goals towards, in the short run, doing some things in order to ensure that in the future you always have a lot of aardvarks around, so that you can continue in the long term to reliably be near the beginning of the alphabet. But that's like a different kind of agent. Is the relevant thing that its preferences are defined purely over the action space and not over, like, the world state or world histories in any way?
I agree with definitely the first part, that this is very distinct from an agent that wants to take the first action sorted lexicographically. I would more say, I mean, you say that, like, then your second part was like, is the distinction that the preferences are over actions instead of states. I would somewhat say that it doesn't have preferences, because, like, I'm imagining a program that's like, take the list of actions, sort it lexicographically, take index 0 and execute that, right?
Yeah.
That thing definitely does not have convergent instrumental subgoals.
Right.
Like, if you suddenly give it the take over the world action, well, the take over the world action is still not lexicographically versed, and it's not going to take it.
Yeah.
Right.
But, like, okay, to the extent that it has preferences, they are over the actions rather than the...
Yeah, I guess you can model it that way. That's not an unreasonable way of modeling it. It's fair.
I'm trying to think of, like, other examples in that. Like, can you define anything that's purely preferences over actions that would be goal directed?
That seems unlikely if your actions are simple, because if you define preferences only over actions and don't let the agent reason over long time scales, then it's forced to act extremely myopically. It's basically just a reflex agent that just like only looks at which action would be good to do right now with no regard to what the state is. I would be very surprised if anything like that was goal-directed.
But also not useful.
Yeah, it also would not be useful.
Okay. The next question is one of I can't remember exactly which section. You talk about there's a section called all behavior can be rationalized as expected utility maximization, where you have a rather neat construction that I've given here, where you make a utility function, which if you try to write down this utility function, it will be very, very large. And I feel when I read this, I was reminded of Charles' Chinese room argument, which kind of makes the same way to, I don't want to say cheat your intuitions, but you think of when people normally think about a utility function, they think about something very compact. And in fact, here we have a truly enormous. Do you think that's a fair criticism that a utility function that is too large to be written down is not really a utility function?
That seems reasonable. I agree that it's pretty analogous to the Chinese room argument. To be clear, I do think that if you wrote a program where you write down a utility function, which would be sort of by necessity compact and simple, and then you like maximize the expectation of that utility function, I think that is dangerous. I think it has all the convergent instrumental subgoals, and maybe not all of them, depends on what the utility function is, but usually it will have that, and probably this ends up killing us if it's like maximized appropriately well or sufficiently intelligent. My point with this construction is that there's this argument that you can say is that knowing nothing about how in that story that I just laid out, we know that there is an explicit utility function inside of the AI, and the AI is like thinking about that utility function and how to maximize it. So if that's your scenario, then I'm like, yes, I agree with all of the classic arguments. Seems dangerous. I think there's another argument which people sometimes make. It seems common to me. Oh, sorry. Let me turn that off. There's another argument that people sometimes make, which is that, well, let's leave aside, we'll say nothing about how the AI works on the inside, because who knows what super intelligent AI is going to look like. Maybe it's just a bunch of deep learning, maybe like we figure out how to get expert systems to work, maybe we do something entirely different, who knows. It's like we can predict it in advance. What we can say, so the argument goes, and I disagree with this argument, is that since this is a super intelligent AI system, you won't be able to find any coherence violations in its behavior. In particular, it will satisfy all of the VNM axioms, because if it doesn't, the VNM axioms, this is the von Neumann-Morgenstern utility theorem. There are some axioms. You can make the argument that the AI system will satisfy these axioms, because if not, you can like extract resources out of the AI, which you shouldn't be able to do if it's super intelligent. And then then you run forward the argument, you use the von Neumann-Morgenstern utility theorem, and you say, therefore, I can model the AI system as optimizing a utility, the expectation of a utility function. Even though I don't know exactly how the AI system works on the inside. And I think my point is that if you're trying to run the argument as like, I can model the behavior by a utility function, that's a vacuous statement, because you can model all behavior as a utility function. And like when you run the argument this way, there's no reason to expect the utility function to be simple or compact. Like, you need some other sort of assumption in order to get to a simple, compact utility function.
That makes a lot of sense. I've tried to elaborate a bit more here on the next slide on basically not just what would the AI have, but what is actually inside our heads. Is it compressible? Well, again, try to make a scale, like it could be something really trivial, or like just evolution, basically. And there was a philosopher, I forgot who, it was quoted in the sequences, that wrote down like 50 different things like friendship and love and art and novel experiences and all this kind of thing. And then what we will probably see in naive, ambitious value learning, if that's possible, which is something still possible to write down on a piece of paper or something like that, and then something that can't be smaller than a brain, and something that is even larger. Is this a reasonable model here?
Yeah, I think if you're going to use human values, that makes sense. I think there are some decent arguments that, like, what we should be thinking about is not exactly human values, because they're not really well defined right now, and we should instead be thinking about the process by which humans have values. So like this argument comes from many people, but Gillian Hadfield is one that comes to mind. But if you're going to use human values, my guess is that they're going to be in the highly complex region. It's not obvious that that's the case. You could imagine that, like, after a long period of deliberation, all of humanity comes to the consensus that actually no, it's like hedonic utilitarianism with this very simple definition of what happiness is. After we've like solved problems of consciousness and whatnot, and then you're like, okay, that is in fact just what our values are, and then that's like pretty simple, and we can encode it into an AI system. I'd be surprised if that happens, but it's not inconceivable. Yeah.
Okay. Again, please feel free to jump in if you have any. Yeah, sure.
Could you maybe go into more depth about the argument that we should care about not human values themselves, but the process in which they arise, or at least point me towards somewhere where I can become less ignorant about it?
Yeah. I don't know if any good resources written on this. The short version of the argument is humans don't really have any consistent set of values. Lots of people have like very different moral intuitions.
You caught me. You caught me.
Yep. Very different moral intuitions, lots of different approaches to ethics, especially when you posit weird thought experiments that aren't in like situations that people normally encounter. So like, it doesn't seem reasonable to say that humans have values. It seems more reasonable to say that humans have norms which are suited to the current context in which they live. If you change the context, the norms need to be updated and changed, but that doesn't just sort of happen automatically. We've seen this like in the past as technology progresses. So, as soon as if we ever get, for example, the technology to upload human minds and then make digital copies of minds, currently we have a norm of every entity, every being, every person gets one vote, and everyone's votes count equally. In the scenario where we've got a bunch of digital minds that can copy themselves, that is not going to work very well, because at that point it just becomes whoever has the most money can just create a bunch of copies of themselves, and they form a giant voting block that gets whatever they want to be passed. If we're still using democracy with one vote, that's equal to every being. And so something will have to change there. We'll have to change norms somehow. But, you know, yes, like a utility monster. Well, I feel like a utility monster is different, but sure. Anyway.
And just to elaborate, the process by which we uncover these values, I think Wei Dai suggested like a two-step process where first we spend 1 million years figuring out what our values are, and only in the solar system, and then once we have figured that out, then we tile the rest of the universe or something like that. And I guess in the first step, where we are just trying to figure out our values, it doesn't actually need to be very optimal, right? Then we can have a very suboptimal process there, and then as long as we don't optimize it very much, Gotthart's law is not going to be a problem.
Yeah, that seems right. I think I agree with that, to the extent that we figure out how to do that. Yeah. Oh, one more example I like, actually, of this like learning values or values updating over time. Like, I recently found out that privacy was not a thing in the past. At some point, like bedrooms were invented, and they were still like somewhat public, but over time they became more private. And now sort of everyone thinks of privacy as this like deeply enshrined value, at least in the West. And it just was not for most of human history. And that seems like the sort of thing where the norm, I still don't know why privacy evolved to be one of our values, but this is the sort of thing I mean when I say that like there is some sort of process that creates values and they change over time, and we probably shouldn't be like trying to figure out what human values are and then hard code them into an AGI or something like that.
But I kind of have a counter argument to that, saying, well, I don't really, or at least I care about my current values. And like, I get that the process which created my values wouldn't necessarily create my values in any situation. But I mean, they did create my values, and I care about my values, not any other, not any other possible me's values. Except for the fact that one of my values is that I care about other people's values. But, disregarding that, it's like, now that I exist, I have a strong bias towards my current values. So wouldn't you say that, or wouldn't creating AGI that is based upon the process not fulfill my values as well as just trying to fulfill my values?
I predict as an empirical fact that, or like this is an empirical prediction, that whatever you call your values right now, even if that like you would of your own will, free of manipulation or whatever, change them somewhat as new technologies get invented. For example, I think the democracy example is a good one.
Yeah, good sure. I mean, I'm gonna change my values tomorrow when I wake up and I'm like a bit sleepy, and I'm probably gonna be less tolerant of most things than when I'm like, doing very well. So like, my values change within a single week. So yeah, that's a really good argument.
Yeah, I think I'm just saying, note that there is change in values, and sort of the entire point of thinking of human values in the first place was to give our AGI system a description of what we want that can stay static and that it can optimize forever. And I'm just like, I'm not sure such a static description exists even in principle. Maybe it does. You could imagine something like what I would think if I were given like 1 million years to think about it. And maybe that's sufficiently good that as a static description that it works. But I don't know.
Okay.
Well, I'd just like to just add something there. I'm reminded of, today I came across the term flashlight method of writing, say, a novel. And the idea, somebody said that writing a novel is like driving a car in the dark. You can see as far ahead as your headlights show you. But that is enough. Being able to do that is enough to complete, a very long journey by car at night, and you can get through a whole novel. But if you can just write, say, one scene at a time and see what develops from that. Whereas, I mean, some writers don't like that. They prefer to know the route map of the whole novel. And it seems to me that developing values is like this, that it would be a crazy dream to think about anything convergent by the way of our ethics that's going to last a million years. And that we can only try to produce systems, artificial intelligence, political systems, anything like that, which we can endorse, but which have enough flexibility and development in them that our grandchildren can carry things on, and they will endorse things that we wouldn't approve of. Just as we approve of things that our great grandparents would not have approved of. And as long as each generation can endorse what, say, the next two generations do, then we can just progress that way without any sense of heading towards an ultimate goal that we can visualize.
I pretty strongly agree with this. I think Soren has some questions for me about exactly that perspective later on.
I believe I have. Yes, I'm just thinking about what that question was. But in the meantime, if we are continuing, then actually I had some questions a bit more about strategy and AI safety strategy. And I have Wei Dai. I don't have a picture of him. There are no pictures of him. But he says that one of the points of goal-directedness is that you get economic efficiency for free. And then you answered in this comment that hopefully we can convince the relevant actors that goal-directed agents have a significant chance of causing catastrophe. And I've tried to write down why I'm a bit less optimistic about this. If we think as an example, the people who are right now using the strongest computer to simulate nuclear weapons, they are obviously very insensitive to this kind of argument. They probably don't care very much about existential risks, and they care about a lot about their country's power in the same way. And this requirement that we can convince all the relevant actors, it's a very, very strong requirement. And I'm wondering, could you give some more details? Do you truly believe we can actually make everybody stop building goal-directed agents to avoid some kind of competitive scenario?
Yeah, so I think there's a pretty entangled set of beliefs that make me say this. Part of it is that I don't think there will be that many actors that are building very powerful AI systems. Like, it seems based on the current state of the art in AI research that you need just a lot of compute for it, and it's actually quite expensive. Which is sort of what you'd expect from the outside view, that like big projects that are very impactful upon the world will be expensive. And so hopefully there won't be that many actors. So that's one thing. I think another thing is that, like, sort of in an abstract sense, I think everyone agrees that extinction is bad and we don't want it. And it's like significantly worse than most of the upsides you immediately get by building powerful AI systems. I'm not sure of that last part, but it seems plausible to me. And like right now I'm I believe that a bit more than like, oh, extinction is like comparable to like building an aligned superintelligence that's aligned with you. I don't know. It seems to me that like most actors have like, or most large actors anyway, have like a decent amount of shared interest of like, yeah, humanity prospers, everyone is like not in a is in a post-scarcity world types, things like that. And so I think we can maybe hope to get agreement that like, yeah, the extinction risk is really just so large that even though there would be benefit from making powerful AI systems to each actor individually, that's like not worth the extra risk of extinction that they would have. So that's another thing. A third thing is sort of a disanalogy with nuclear weapons, which is that for nuclear weapons, nuclear weapons do not automatically go to extinction risk. If one country has nuclear weapons, then they have not very much downside to themselves, because if they bomb some other country, it's a problem for the other country. It's not much of a problem for them. And there's upside in that there is upside. AI will also have upside, which is being able to have more geopolitical power. But sort of the downside is very different, in that the downside is a different country gets extinct, basically, but not us. Whereas with AI, to the extent that we're concerned about accident risks and not things like lethal autonomous weapons, which I think is what we're focusing on here, accident risks just affect the entire world. So that's one disanalogy. You might argue that at this point today, nuclear weapons are an extinction risk, and so why aren't we disarming? I think for that, I would say nuclear risks are only an extinction risk because of mutually assured destruction. And if you stop having mutually assured destruction, then nuclear weapons no longer become an extinction risk, and so you have all the incentives for having them again. And so in order to be in I don't know if it's stable, but to be in this equilibrium that we're in right now, where where the world is not where nuclear weapons aren't really being used, that might actually just depend on mutually assured destruction being a thing. And I think in mutually assured destruction, it probably makes sense for supercomputers being used to simulate nuclear weapons, because each actor needs to make sure that no other actor gets too far ahead of them. First strike and second strike capabilities in particular are very important under MAD doctrine. And notably, none of this applies to the super intelligent AI case.
In this task of convincing that we might have to do you expect we can do this in our current epistemic state, or will there need to be some changes, either more research being done or some kind of fire alarm for AI safety? And if there's a fire, how?
Yeah, I don't think we can do it with our current epistemic state. For one thing, I'm in this research field. I've thought about it for quite a while, and I'm not sure what kinds of extinction risks are there, or what's a dangerous thing to build and what's not. So I think we need to have a much clearer picture of that. We probably would need to build agreement among AI researchers, at least, before we could convince more all larger actors.
I don't think there is an extinction risk that's disputed. So until we get that dispute out of the way, debating what extinction risk is far out.
Yes, that's true. Yep. Yeah. So all of this, I think it's actually not that controversial among AI researchers that an expected utility maximizer. An expected utility maximizer with an explicit utility function that was super powerful would end up killing everyone. I think the part that people disagree on is more whether or not we will build such a thing, and how far away it is. Most of the arguments seem to be, why are you worrying about this? It's way off in the future. Who knows what sorts of AI systems we're going to build? I don't see very much argumentation that's of the form, or I'll see arguments of the form, we will never be able to build AI systems that are that powerful. I don't really see arguments of the form, even if AI systems are that powerful, they will not kill us. There are some, but it's pretty rare.
It seems to me like the vast majority of people who are actually building AI, maybe not AI researchers, but people actually using this, are strongly not caring about this more than they disagree. So it's more. It's not because they. Yeah. Do you think that's true?
Yeah, I think that's basically true. I might, especially if you're not talking about AI researchers, that seems very true. I do think that, I mean, I'm hopeful that we can like build better arguments such that people do in fact get convinced. But even if that ends up being too hard a task, I do think there will be like fire alarm type events. Not for AGI is coming, but for our current AI systems fail in weird ways that are dangerous. So like a sort of example of this right now is like the way that recommender systems optimize for basically people being angry at each other all of the time. I think we've like basically all agreed, at least in the AI researcher community, it seems not controversial to say that. I think people agree about it. This isn't exactly a fire alarm because you can sort of see, okay, this is the algorithms are like not particularly smart. They're like operating in this limited domain. So to go from that to like, oh, powerful AI will kill us all is definitely not a step that is really justified, even in my opinion. But I expect that these sort of warning signs will become more and more impactful and more obviously connected to intelligence as time goes on. And that, I mean, I don't like this fact. It probably means that there are like very just large harms to humans. But it is good in the sense that it probably will get more consensus on here are the dangers of AI and allow us to coordinate to not have those dangerous AI systems.
Okay, great. I have more questions. And that's about AI safety without FOOM. One of the things I asked you in the email correspondence was what parts of Nick Bostrom's book Superintelligence and Yudkowsky's arguments that you were most disagreed with, and about half of your arguments focused on arguments against FOOM, the quick takeoff. So I'm wondering, in the situation where we don't have a FOOM, we don't have an intelligence explosion, but we do still have what Bostrom calls a medium speed takeoff, where there is time for an AI race that over 1 year causes people to go from a very, very basic AGI to something that is super intelligent. Do you feel this is how dangerous do you feel this is?
That's a good question. So when you say stupid AGI here, what do you mean? Do you mean like level of humans?
Let's say you can simulate the reasoning of a human with like an IQ of 90 using huge amounts of compute. So It's obviously not economically viable, but this is something that it's very amenable to improvement. So it can be improved, and over 1 year will be improved to a superintelligence.
Yep. Okay, makes sense. Yeah, that is quite fast but plausible. I think sort of part of my general optimism about us solving these problems is that I would expect that within that year, we will notice something going wrong, if something actually would go wrong, and update based on that. I agree that there would be, well, there's at least time for an AI race to happen. whether an AI race would actually happen is less clear. I'm sort of hoping that by the time we get to this world, we have some more better global coordination, better understanding of risks. I'm not sure if that's actually true. Yeah, odds that after this year we would wish we had worked more on AI safety. I feel like this is really contingent upon how this happened. Maybe if I assume, okay, right today is when the stupid AGI gets built, and then in 1 year it's going to be super intelligent. I am pretty scared of that scenario. That scenario seems quite bad. Yeah, but mostly that scenario seems quite bad because most of my models seem wrong in this world, and then I'm like, okay, in this world, it looks more like we have somehow created an AI system that's really smart and has already become like really useful to society, and so can't be turned off. Or like there's no will that will let us turn it off, even if we could. Yeah, but really I want to express large amounts of uncertainty here, mostly because the scenario seems to depend on a lot of like external details of how the world works or how we got to this point.
Okay, so it seems likely, I'm not really sure about this, that the world is generally trending to some kind of greater cooperation, so that in the future we'll be more able to avoid these kind of very hard races. How quickly do you feel is the world trending towards this? Are we actually moving in the right direction compared to like 20 years ago?
I don't want to speak about the world broadly, but like I think for AI in particular, I think the world is in fact moving in this direction. I think okay, let's preface all of this with, I am not an AI strategy researcher. I talk to some AI strategy researchers sometimes, but this is not what I think about full time. So take all of this with lots of grains of salt. That said, it does seem like the world is in fact moving towards more coordination on AI. I think the Partnership on AI is an example of an organization that sort of seems geared in this direction, and they seem to actually be doing things. Like a worry with any such organization would be that like, oh, it's just PR for the companies, and I wasn't sure if this was true or not, and I think now I'm like more leaning towards the case that that's actually not true, that it actually is likely to get things done.
What made you change your mind?
Oh, talking to people who have more interactions with Partnership on AI than I do. Yeah. Also, you can see some of their output. They have started producing a little bit of output, but that was not the major source of evidence. I think other things are like, I'd actually be interested to know whether or not this is historically true. But this might be a case in which we like foresee a risk before it actually arises. And I now don't endorse this belief, but like my vague guess was that historically we in fact did not foresee problems before they arise. And that was like a big reason for how hard it was to fix them. But as I say that, I realize I wouldn't actually know if we did in fact foresee problems before they arose. So maybe we did and just didn't do anything about them.
It is really hard to figure out what are appropriate historical parallels.
Yep.
Okay. Then I have another question about narrow AI and ambitious AI, in that In chess there is this kind of, obviously in the beginning humans were better than the AIs, and there was a time where cyborg teams of humans and AIs were both better than the humans and better than the AIs themselves. And then eventually, of course, the chess algorithms get better and better until we get to the point where the humans are just in the way. Do you think this is a reasonable? You talk quite a bit about the humans provide the goals, and then the non-goal directed AI helps. And this seems like a strategy that would be dominated at some point by just goal directed AI without the human. Do you feel this is correct?
I think if you can define the task that you want done, that is probably true. But given that we almost always cannot do that, like in chess we can do that. Nice property of chess and Go. But given that we cannot in fact do that for almost every task, I think there's probably some sense in which there will be a goal-directed AI that is more intelligent than the human plus non-goal-directed AI. But I doubt that there is a goal-directed AI that is more useful than a human plus non-goal-directed AI. At least, or like if such a thing exists, that goal-directed AI is somehow getting its goals from a human. Yeah. Or like optimizing to help humans or something.
One of the goals that I had in mind was something simple like earning money. In this case, defining the goals is really, really easy. You just have a bank account and you want to make this number as high as possible. And yep. in this kind, it's almost as easy as chess to define the winning move. What is the winning move and what's not?
Yeah, I think if you limit your AI system to like it's only allowed to trade stocks or something like this, and can't do anything else, then I probably agree with you. But also in such a scenario, I think the AI system is pretty safe. Like the model of an AI system where it ends up killing us all requires the AI system to have a very good world model, a good understanding of the world, and be able to like take actions in the broader world. Now, sometimes you can definitely talk about how it could use the limited set of actions it has in order to figure out ways of influencing the real world or the rest of the world in a way that you didn't intend. But that seems to me to be quite a difficult learning problem, actually. And I think if you got to a point where an AI system was able to do that, you've probably trained it on a pretty large, diverse set of data about the real world. That was very fuzzy, sorry. But I'd be surprised if it just sort of discovered this way. Would I be surprised? I don't know. Yeah, maybe I want to just express confusion and uncertainty for this question.
Fair enough. Then I will go to the next question, I guess. I don't know if Stuart Armstrong has managed to join us here, but one of the earliest part of the sequence was where he tried to use Kolmogorov complexity to see if it was possible if assigning correct values to humans had a lower Kolmogorov complexity. And he found in this that basically you can't do this. You can assign any value to humans. But this seemed to me like the way humans do this. Of course, we have things like Hanlon's razor that says you shouldn't assign to malice what could be explained by stupidity. And the same way, if humans fail to multiply two very, very large integers, it's probably not because that's our value, it's because we can't multiply this. And some of the examples that Stuart Armstrong gives, like perfect anti-rationality with the opposite goals, that's obviously also something that humans, we basically never consider that, because we don't operate with a Kolmogorov complexity only. We have some kind of a human brain, and given that the person in front of us is a human with a brain that looks roughly like our own, then what is the simplest explanation based on that? Do you think a scheme like that could work?
I think the challenge with any scheme like this is that you have to make some sort of assumption about the human. So if you don't make an assumption about the human, then, or just generally, when you're inferring values and you want to distinguish them from bias, there's like one way to think about it is that there's this values object, and they go through biases in order to produce behavior, and the behavior is not optimal with respect to the values because of the biases. And sort of the post after that one, or before that one, I forget the order I put them in, by Paul Cristiano about the easy goal inference problem still being hard, sort of makes this point that like in this situation, if you want to get, so the thing that you observe is human behavior, and you need to decompose it into values and bias. If you want to, and then you can once you do that, you can take the values and optimize it to get a better behavior, which better optimizes for our values. Now, if you want to outperform the human behavior, that means you need to figure out the direction of the bias, or the mistake model, as he calls it, which sort of I see the sort of Stewart's result as saying, well, you can't just learn this model, and yeah, you can't just learn what the human biases are, which means you have to put some assumption about it. And so then the values that you infer and the optimal policy corresponding to them are only as good as your model of human biases. And I think that it is pretty hard to get such a model of human biases. And sort of even if we did, to the extent that we're trying to do ambitious value learning, I like take it as basically axiomatic that any model we make would be misspecified somehow. Like it won't perfectly capture human biases. And the last two posts of that chapter by Jacob Steinhardt and Owain Evans on misspecification sort of argue that when one of your assumptions is pretty badly wrong or is misspecified, lots of bad things can happen. And I would expect this to happen, especially if you were trying to do ambitious value learning.
I probably agree with that, but I just point out that some of the examples of biases, you could probably look at a human brain and then say, okay, when the human is asked to multiply two very large numbers, he answers, I do not know, and from looking deeply into the brain, you can figure out that is because the human brain is unable to multiply these two large numbers. So it's a mistake from the human that he doesn't give the right answer, rather than because it's his value to say, I don't know. I mean, this seems like something that could work and could be expanded, obviously.
Yeah, that seems right. Yeah, what do I think about that?
Let me just check if Stuart Armstrong has joined us, because he might have a comment.
Yeah.
No, I don't think he has joined us.
Yeah, I guess in the multiplication case, there's a notion of correctness. And I think you're basically making... I think you're making the assumption, like if I were to take this frame of how do you decompose values and biases, I think you're like essentially making the modeling assumption there that... Actually, okay, yeah, I agree. You could like sort of look at the human brain and be like, this particular information, in particular, the product of these two numbers never appears in the brain. And maybe that allows you to infer something. Yeah, I'm not sure. Maybe there's something to do with this. I think I would be surprised if this like managed to get you all of human biases. Like you could get some, and you can make some progress with it, maybe. But it seems very difficult to figure out. Like, certain notably, humans also are not able to do this. Is it like a bias that we care more about people closer to us geographically than far away? Or is that just part of our values? Effective altruists will tell you it's a bias. Lots of other people will tell you it's a value.
I think I agree with this. Just to be clear, we've now spent 1 hour and 10 minutes on this, and if you need to go, then please stay. So otherwise, I guess we have time for a few more questions.
Yeah.
So
I should have quite a bit.
well, if you don't mind, then I don't mind either. And one of the more controversial statements that you made is that this article by Eliezer Yudkowsky is in fact vacuous, that a superintelligence will look like an expected utility maximizer. And the argument is, as I see it, are arguments against some straw arguments. For instance, that in history there's been a lot of cases where a less smart person has outsmarted someone who is smarter, and that might be a way to have AI safety. That even if the computer is really, really smart, then it might be book smart, nerd smart, and don't know anything about politics or power or something like that. And in this case, then by modeling it as an expected utility maximizer that cannot be cheated in this particular way is like a counter argument to that. Do you feel that some people hold, maybe not explicitly, this the first straw argument, and do you think that the article is a counter argument to that?
Sorry, I'm not actually sure which one this is supposed to be representing. Is this a straw version of Eliezer's argument or my argument?
No, third person, really. Imagine someone who is not particularly worried about AI safety, because he believes that if we build an AI, then sure, it might be really good at mathematics, but we'll still be better at military stuff, and that's why we will be able to defeat it. And then actually it will we won't have any easy way to cheat this machine.
I see. I have not actually run across anyone who really claims this first argument. Maybe I've heard it occasionally from like random people, like Uber drivers and things like that, people like that who I end up talking to about my research, but not from anyone who's thought about it seriously. But I agree that some of Eliezer's writing would be a good counter-argument to this naive straw argument.
Then the other straw argument, that you imagine someone who is talking about AIs and could imagine that he's writing a computer program, and then suddenly this computer program is really, really smart in some way. And even though this computer program is really, really smart, it might have some kind of mental flaw or vulnerability. And Eliezer Yudkowsky's argument here seems to be that you can have both things that are intelligent and things that are optimized. And if you have a being that comes from nothing, maybe a random coincidence, then it might be exploitable. But if it became super intelligent through some kind of optimization process, then it cannot be exploited. Do you feel this the article could be a counter argument to this kind of straw argument?
Interesting. Possibly. I did not have that reading of Eliezer's article, but that doesn't mean that's not what he meant. Yeah. I don't know. I don't think Eliezer's article is a very compelling response to that particular straw argument. It's like, okay, for sufficiently intelligent AI systems, that seems true, but like, that sort of just I think Eliezer takes as an axiom an axiom of Eliezer's article is if we have a super intelligent AI system, it can and will do any cognition that we are capable of. I think if you have that assumption, that's already a counter argument to the straw argument too, and you don't need the rest of the article that he's written. So I would really say it's more just an assumption of his argument as opposed to something he's arguing. That said, I also don't see very many people who argue this straw argument too.
I imagine. Sure.
Yeah, I imagine that, or maybe we're gonna say the same thing. Let's find out. Like, I could imagine that it kind of comes down to the presumptions you make about what is a super intelligence. Like, I could imagine an intelligence which works out all of mathematics way before it works out human interaction. Maybe that's just a much more complex problem to solve than most of mathematics we would consider harder than human interaction. But maybe that's also, or maybe that's not the case. Maybe there's super intelligence which just works out both at a similar rate, and then that would not be the problem.
Yeah, I mean, I think I agree that the AI systems that first seem like super intelligent on like pretty complex tasks will in fact seem not as intelligent as humans on other tasks, and social interaction seems like a pretty likely one. I think Eliezer is definitely thinking of like AI systems that are beyond that. It's just like saying, at some point we will hit a level of intelligence where it just outperforms humans on everything by a lot.
Hence why the making very clear what a super intelligence is.
Yep. Yeah. I should also say, I'm like not sure I understand what Eliezer's saying. It's not clear to me that I've understood what he's trying to convey, but I'm taking my best guess.
The thing I was trying to say before is that my model of Eliezer Yudkowsky is that he basically is bombarded with bad arguments against AI safety. So he is probably intimately familiar with a myriad of bad arguments. So like these, I think he has at least double-digit times people have said to him that the AI will just be book smart, but will be politically smart, so it won't be a problem. I think people will... So that's why he cares about countering this kind of argument.
Yeah, that seems possible. It definitely sounds like that to me as well. I don't actually know. But like, he also does use this, like he does use this argument in a way that's like, this is why we care about utility functions. And I do in fact pretty strongly disagree with that. Like sort of the best example of where he's using it that way is in it was a talk called AI Alignment, Why It's Hard and Where to Start. I believe that was the title. Also, like, man, if he's responding to straw arguments, I'd really wish he'd just say that these are straw arguments before I spend all of my time reading something that's meant to argue against a thing that I very clearly do not believe.
I've just started reading your summary of about comprehensive AI services, and I'm very intrigued by that because it seems to describe a much more plausible route to AI, AGI, if that's what it is. Than you know the sort of single entity, super intelligent entity that Eliezer and Nick Bostrom seem to have in mind all the time. Can you say something about how that? What do we call it? Do we call it case or case or?
I call it case just because case is also an English word.
Yeah. Okay. Can you say something about how case relates to this? Slots into this whole value learning approach?
Oh man, yeah. If only I had a good answer to that. Let's see. I think a thing about one thing is if you look at sort of the chapter 3 of the value learning sequence, the narrow value learning part. I think most of that is more compatible with KAIS than things like ambitious value learning, in that you could have a service, and Eric talks about this in his full report on KAIS. You could have a service that predicts human approval. So you give it a plan and you say, hey, are humans going to approve of this plan? And it says either yes or no. And you can use, or maybe somewhere, degrees of confidence. And you can use that information. Other services could use that information as needed. You could use that to monitor all of the plans that other AI services are doing and see, oh, hey, this service doesn't seem to be doing things that humans would approve of. We should probably check that, maybe update it somehow, figure out what's going on. So that's one way things could be in there. That's one way that narrow value learning could interact with KAIS. I think more generally, just like treating narrow value learning as a service that other services can call upon makes some amount of sense. You could imagine, for example, a personal assistant or like a flight booking assistant that is like, you say, hey, can you book me a flight to New Orleans on Friday? And it looks and it sees, oh, hey, there's a flight, but it's a red eye, or maybe it's like $2,000 for some reason. And then it's like, that's suspicious. That's like weird and probably not what the human was expecting. Let me call upon my narrow value learning service and try and figure out what the human actually wanted, and then present a bunch of other options. Like maybe you suggest that I take a flight on Thursday instead because it's much cheaper and it won't be overnight. Yeah, it's not much of an answer, but that's something I hope.
Thanks.
I should also say that hopefully the AI safety reading group will get to Eric Drexler's report if we can find something, find some parts of it that is relevant, because the entire thing might be too much and your summary, Rohin, might be a bit too little. We need something preferably 10 to 20 pages, but that's going to be quite a challenge to find.
Yep, that sounds right.
It's very large.
You could do something like my summary, Richard No's summary, and Robin Hansen's blog post about it, along with all of the comments on all three of those.
Yeah, that might work.
Mm-hmm.
Okay. So while I was trying to summarize your the value learning sequence, then there were some times where I tried to draw some kind of models where I was actually unsure whether you would approve of them. And so the first one I have here is that we imagine that we have narrow value learning that is working in a very narrow sense, and then we use this kind of loop to build some kind of norm inference where we figure out what should the AI not do, and while we do, the AI is trying to work within the framework of norm interference. We want to gradually transition to something more ambitious value learning. Does that seem reasonable?
I think that's broadly reasonable. I would make two clarifications to that. So one is the way I defined ambitious value learning, which was in some sense a straw definition and extremely rigid. I think that you would just never want to do ambitious value learning. But if you take a more normal sense of what that would be, of like, all right, we want to figure out, all right, how we could make a good future, and it's not a utility function that prescribes exactly what to do in every single particular environment, but sort of general paths that are general things that we want with like maybe some correction by humans along the way or something like that, then I think it's pretty reasonable. I also don't know that I would say narrow value learning will lead to norm inference. They feel somewhat like two parallel strands of research. like, I guess my intuition is that, like, if you wanted to infer the values of a single agent, the things you do are just quite different from what you do if you want to infer the norms that a set of agents are following. That's my intuition right now. I don't have a great justification for it, but they do feel like parallel strands of research and not that narrow value learning feeds into norm inference.
Okay, great. Then I had another kind of maybe a Venn diagram or something, where we have the set of all expected utility maximizers, and as a true subset of that we have the goal-directed agents, and as a true subset of that we have the explicit reward maximizers, where all the subsets are true, as in there are goal-directed agents which are not explicit rewards maximizers, etc. Does this also reflect your thoughts?
So if by expected utility maximizers you mean just any agent, because everything can be modeled as an expected utility maximizer, then I think I agree with this. This seems right to me.
Okay. Then I have a question here, which I believe you have roughly answered. You have answered that this fact that intelligences should have voting rights would be a norm that we prescriptively have right now, that probably won't be changed. And then one of my also points was that if you look at human norms descriptively right now, you also run into a lot of problems. Like might is right. So do you feel descriptive norms or prescriptive norms are what will be basing the norm inference on?
Probably descriptive ones. Just because that's sort of what inference means. It's like you observe what is actually happening and then figure out what the norms are. I do think that, like, with norm inference, you also want to figure out the process by which norms are updated over time, which currently is, well, there's some like opaque social process by which it happens, just among communities of people, but there's also like law and court and judges and courtrooms and things like that. So this is not my area of expertise, but you'd probably want some way both of inferring what the current norms are and also a way of figuring out how the norms should update in the future. I don't have very much clarity on this, though.
Okay. Then another option you wrote about is that to have the AI have some kind of estimate of what its rewards function should actually be, and then you write that the AI should have an estimate that would be an obvious thing to implement. And I agree that having the AI estimate what should be its own true reward function is probably easy, but if the reward function is not compact, or if the reward function is compact, then it seems quite hard to implement in practice, right? You imagine that there is one option is that the human, what they actually truly value is paper clips and nothing but paper clips, and another hypothesis is that humans care about reproductive fitness and nothing but reproductive fitness. You have a third, which is like pure hedonism or something like that. And if you want to have an estimate of all the options, then enumerating all the options, of which I just had 3 here, seems really hard to implement.
Yeah, I actually don't remember what context I said this in, but my guess is that I was making more of an abstract theoretical point that wasn't. When I said the most obvious implementation, I meant more like if we had unlimited compute and the ability to like have a prior over all possible reward functions. Do you remember which post this was in?
Let me see. I might be able to find it. Let me see if I can. There's a search here. So let me just the most obvious implementation. Here, reward uncertainty. Let me just see. If
Yeah, okay. I was trying to make a more abstract point here. I should probably update that and make that clearer.
Okay, fair enough. It was just if there might have been something obvious that I missed here. Then this is actually not a question about for you. I might want to put it to Owen. Let me just see if I have other questions that I think I would really care about. There is corrigibility. What is the relationship between corrigibility and value learning? Because you end up talking quite a bit about corrigibility, and it seems, what is the relationship between these two concepts?
Yeah. Yeah, I think I got more clarity on this since writing the sequence, so hopefully I should be able to give a better answer now. So the way I think of corrigibility is it's the property that your AI system is trying to help you. Whereas value learning is about whether the agent knows what it is that you want. And these are somewhat orthogonal, in that value learning is more a statement about like the agent's knowledge, whereas corrigibility is more a statement about the agent's motivation. And you can either say, I am going to create an AI system that is corrigible, meaning that it is trying to help me, and then as long as it meets some basic level of competence of like intelligence or something, then one of the things it will try to do when it's trying to help me is it will try to learn my values or my preferences, perhaps. Let's ignore values for now. And so there you could say, okay, I'm going to build a corrigible AI, and that will lead to value learning. Also, to be clear, this is I think this is Paul's notion of corrigibility. It is definitely not Miri's notion of corrigibility. We have two different meanings for the word corrigibility, at least. It's not great. I just wanted to note that first.
Could you briefly say what is the difference between Miri's and Paul Christiano's definitions of corrigibility?
Yeah, so the one I've been using so far is is what I think Paul's definition is, though I've been known to misinterpret Paul before. The Miri definition is more like it basically gives you a fallback mechanism, so that if you say, for example, turn on AI system, you are doing a bad thing, turn off now, it actually just does turn off. No questions, no like inference over reward functions, no like modeling the human as rational or irrational, nothing like that. It just turns off. So in this sense, it like there are some situations, some situations where a human can activate a fallback mechanism that provides robustness in case something has gone wrong. That's, I think, the Miri sense of corrigibility. Cool. So I'll go back to the original question. So with the Paul sense of corrigibility, where the AI system is trying to help you, that can lead to preference learning, as long as the agent is at least somewhat capable. Conversely, you could talk about, okay, I'm going to build an agent that does value learning or preference learning, and then it's going to optimize for my preferences or values as based on what value learning and preference learning it's doing. And then if it's like reasonably competent at learning my preferences, it will learn that, hey, I prefer that it listens to me when I tell it to shut off. I prefer that it doesn't deceive me. I prefer that it not kill me, etc., etc. And as a result, it ends up behaving the way a corrigible agent would. Or like it learns that I prefer that it like helps me in general, which is sort of the property that corrigibility is supposed to be. This is assuming an agent that does preference learning and then optimizes for my preferences. So that's sort of, there are two parts of that. One is the preference learning system, and one is how you optimize that.
Okay.
Also, with preference learning, there's often reward uncertainty is a component of that. And I think the reward uncertainty automatically gives you some of these properties as well. So really, there's like, you could either try to build a corrigible AI and get preference learning out of that, or you could build a preference learning plus reward uncertainty AI and get corrigibility out of that.
Okay, thank you for that clarification.
Mm-hmm.
Then I, in one of there's the concept of having a AI as a controller and having a plan. Then I made a statement earlier that sometimes the plan would be better than the control if the plan was good enough. I think I used a metaphor like if you're trying to navigate a maze, then the plan of always sticking to the left wall is a good plan, and a controller in this situation would be a bad plan, or would perform worse. And then I think in this you're right that actually in control theory you can prove that a controller is superior to a plan, and then there's no link, unfortunately. So I couldn't actually go and see where my assumptions are wrong. Can you sketch roughly why I'm not right with my maze example?
Yeah, so I think actually in your example, the plan of the thing you're calling a plan of like always going left, or sticking to the left wall or right wall, whichever, it doesn't matter. That would actually be a controller in this terminology, because you are relying on the ability to choose your actions after seeing your observations. So like a plan in the maze finding setting would be something like, I must walk forward 5 steps and then turn right and go forward 3 steps and then turn left and go forward 1 step, then turn right, go forward 10 steps, and so on. Which in the case of a maze is fine and would work if you get to see if you make the plan after when seeing the maze in advance. And so in that setting, both a controller and a plan would work just fine. But that's assuming that you can predict the environment perfectly at the time that you make the plan. If you cannot, in fact, predict the environment perfectly when you make the plan, then you need to like use your observations in order to note when you basically need to use your observations in order to like constrain the possible ways the environment could be. And once you have constrained those possible ways, then there's an action that always like guarantees the property that you want. But if you can't constrain the states, but the way the environment is by using observations, then there's no plan that would actually let you accomplish your goal or satisfy whatever specification you have. There wasn't a link because I don't know if anyone has ever written a paper that just makes this point. I think it's obvious to people in control theory or something, and they haven't actually bothered writing it down in a paper. There are papers that prove these guarantees with adversarial environments. That definitely is a thing.
Okay. Let me just see if there is. I guess that will probably be all. So, does anyone have any final questions for Rohin? Then I will say thank you very much for joining us. It's been a pleasure, and we've learned a lot, I think. So, thank you very much.
Yeah.